Hello everyone, welcome to our channel Off Campus. Please subscribe our channel Off Campus and click on the bell icon. You will receive notifications. Okay, let's go into the video. In this video, we are going to see some important MCQs, multiple choice questions and answers in electromagnetic field theory under magnetism and electromagnetism. Let's start. Tesla is a unit of 4 different options are given: field strength, inductance, flux density, flux. Tesla is a unit of which one? Flux density. Flux density, what is the unit for flux density? Weber per meter square. Otherwise, it is called as Tesla. So, option C, flux density is the right option for this question. Next one, second, a permeable substance is one. A permeable substance is one which is a good conductor, which is a bad conductor, which is a strong magnet through which the magnetic lines of force can pass very easily. So, a permeable substance is one through which the magnetic lines of force can pass very easily. Option D is the right option. Then next question, the materials having low retentivity are suitable for making weak magnets, temporary magnet, permanent magnet, none of the above. So, the materials having low retentivity are suitable for making option B, temporary magnets. Then question number 4, a magnetic field exists around iron, copper, aluminum moving charges. A magnetic field exists around moving charges. Option D is the right option for this question. Next, ferrites are dash materials: paramagnetic, diamagnetic, ferromagnetic, or none of the above. Ferrites are ferromagnetic materials. So, option C is the right option for this question. Then question number 8, air gap has dash reluctance as compared to iron or steel path. So, air gap has little, lower, higher, 0. Air gap has lower reluctance as compared to iron or steel path. Okay, option B is the right option. Then question number 9, the direction of magnetic lines of force is from south pole to north pole, from north pole to south pole, from one end of the magnet to another, none of the above. So, the direction of magnetic lines of force is from north pole to south pole. Option B, north pole to south pole is the right option. Then question number 8, which of the following is a vector quantity? 4 different options are given. See what is that? Relative permeability, magnetic field intensity, flux density, magnetic potential. So, which of the following is a vector quantity? Option B, magnetic field intensity is a vector quantity is the right option for this problem question. Then question number 11, the two conductors of a transmission line carry equal current I in opposite directions. The force on each conductor is. What is the force? What is the formula for relation between force and the current? So, F equal to, in general, F equal to mu naught I1 I2 divided by 2 pi d Newton. So, here what is given? Two conductors of a transmission line carry equal current I. So, I1 and I2 equal to I itself. So, I into I squared only. So, F equal to mu naught I squared divided by 2 pi d Newton. So, the force on each conductor is proportional to I squared, proportional to distance between the conductors, or inversely proportional to I. From this formula, see which is F is proportional to I squared. So, option B is the right option for this question. Then, question number 12. A material which is slightly repelled by a magnetic field is known as a material which is slightly repelled. Okay, note this point, slightly repelled by a magnetic field is known as ferromagnetic, diamagnetic, paramagnetic, conducting material. Which one? Slightly repelled by a magnetic field is nothing but option B, diamagnetic material. Then next question, when an iron piece is placed in a magnetic field, 4 different options are given. Which one? Option B is the right option. What is that? The magnetic lines of force will bend away from their usual paths in order to pass through the piece. In order to pass through the piece, Whenever the iron piece is placed in the magnetic field, the magnetic line of force will bend away. Okay, it is the right option. What are the rest of the option? In the option A, what is given? Magnetic lines of force will bend away from the usual in order to go away from the piece. No, it is not wrong. In order to pass through the piece, it will bend away. Whenever iron piece is placed in a magnetic field, the magnetic lines of force will bend away from their usual paths in order to pass through the piece only, not for go away. It is pass through the piece. Okay, so option B is the right option. Here iron piece will break is wrong. The magnetic field will not be affected also wrong. Magnetic field is affected, will bend away. Magnetic lines of force will bend away from their usual path in order to pass through the piece. Option B is the right option. Then Fleming's left hand rule is used to find. See, this is the Fleming's left hand rule. It is used to find the, what is that? This thumb finger shows the force. This is, what is the forefinger denotes the magnetic field, and center finger denotes the current I. Okay, Fleming left hand rule is used to direction of magnetic field due to current carrying conductor, direction of flux in a solenoid, direction of force on a current carrying conductor in a magnetic field, polarity of a magnetic pole. So which one? Option C, direction of force on a current carrying conductor in a magnetic field. See, direction of force on a current carrying conductor in a magnetic field. So option C is the right option. Okay, then 15, the ratio of intensity of magnetization to the magnetization force is known as, this is the formula for susceptibility. Susceptibility equal to ratio of intensity of magnetization to the magnetization force. So option B, susceptibility, is the right option. Then question number 16, magnetizing steel. Magnetizing the steel is normally difficult because it corrodes easily, it has high permeability, it has high specific gravity, it has low permeability. So answer is option D, it has low permeability. So it is difficult to magnetize the steel because it has low permeability. Option D is the right option. Then question number 17, the left hand rule correlates to, left hand rule we have already seen a correlates to which one? Current, induced EMF, direction of force on a conductor. See, we will see before na. Force, magnetic field and current. Force, magnetic field and current. We will see 4 different options are given. See, current, magnetic field and direction of force, magnetic field and current. Okay, option D, current, magnetic field and direction of force on a conductor. Option D is the right option. See, the rest of the options, current, induced EMF, direction not on induced EMF. So this is wrong. Then magnetic field and electric field and direction of force. No electric field. Magnetic field, current and direction of force. Then self induction, mutual induction and direction of force on, no, it is also wrong. Which one is left hand rule correlates to current, magnetic field and direction of force on a conductor? Option D is the right option. Then the unit of relative permeability is 4 different option is given. Unit of relative permeability is nothing but mu, or there is no unit for relative permeability, or otherwise we can say it as it is dimensionless. Answer D, it is dimensionless. Unit of relative permeability is dimensionless. Option D is the right option. Okay. Next question number 19. A conductor of length L has current I passing through it. When it is placed parallel to a magnetic field, the force experienced by the conductor will be, see, read the question again. Conductor of length L has current I passing through it. When it is placed parallel to a magnetic field, it is very important. Whenever parallel to a magnetic field, what is the force experienced by the conductor will be 0. So option A, 0 is the right option. Okay. Then the force between two long parallel conductors is inversely proportional. So we know that formula for force. So what is the formula for force? F equal to mu naught L I1 I2 divided by 2 pi d. Mu naught L I1 I2 divided by 2 pi d. What is given? Is inversely proportional to. So, it is inversely proportional. Force is inversely proportional to the distance. In denominator, see distance only. So, distance between the conductors is the right answer. Option D is the right option. Okay. Then, next one, 21. Material subjected to rapid reversal of magnetism should have large area BH loop, high permeability and low hysteresis loss, high coercivity and high retentivity, high coercivity and low density. Option B, high permeability. It should have, for rapid reversal of magnetism, it should have high permeability and low hysteresis loss. Option B is the right option. Next, question number 22. Indicate which of the following material does not retain magnetism permanently. Does not retain magnetism permanently is nothing but 4 options are given. Soft iron, stainless steel, hardened steel, none of the above. The option A, soft iron, is the right answer. So, for soft iron is the material does not retain magnetism permanently. Okay. Then question number 23. The main constituent of permalloy is, what is the main constituent of permalloy? Cobalt, chromium, nickel, tungsten. Main constituent of permalloy is nothing but option C, nickel, is the right option. Okay. Then question number 24. The use of permanent magnet is not made in, see, is not made in magnetos, energy meters, transformers, loudspeakers. See, the use of permanent magnets is not made in transformers. Okay, answer C is the right option. Then 25. Paramagnetic materials have relative permeability. How the relative permeability will be for paramagnetic materials? So, slightly less than unity, equal to unity, slightly more than unity, equal to that ferromagnetic material. For paramagnetic material, relative permeability is slightly more than unity. Option C, slightly more than unity, is the right option. Then 26. Degaussing is the process of, what is the process degaussing means? What is degaussing actually? 4 different options are given. Removal of magnetic impurities, removing gases from the materials, remagnetizing metallic parts, demagnetizing metallic parts. So, degaussing is the process of option D, demagnetizing metallic parts. Option D is the right option. See, not remagnetizing, it is demagnetizing metallic parts. Degaussing is the process of demagnetizing metallic parts. Okay. Then this question number 27. Substances which have permeability less than the permeability of free space are known. Which have permeability less than the permeability of free space are known as ferromagnetic, paramagnetic, diamagnetic, bipolar. So, option C, diamagnetic, is the right option. So, it previously what we have seen, in paramagnetic slightly more than unity. For in this question diamagnetic, how the permeability will be? Slightly less than, okay, less than the permeability of free space. Okay. For paramagnetic it is slightly more than unity. Okay. It is for ferromagnetic it is very greater than unity. Okay. Then this is one question given problem. Two infinitely long parallel conductors in vacuum are separated 1 meter between centers, then a current of 1 ampere flows through each conductor. Produce on each other a force of, we need to find out the force between. Okay, what is given? We know the formula for force is equal to mu naught I1 I2 divided by 2 pi d, right? Okay. What is given? Current is given. I1 given, current I1 and I2 equal to 1 ampere. See, centers that the current of 1 ampere flows through each conductor. So, I1 and I2 equal to 1 ampere. What is the distance between the wires? D equal to 1 meter. Okay. We know the value of mu naught. Mu naught is a constant value, that is 4 pi into 10 power minus 7. 10 power minus 7 into I1, and I substitute in that formula I1 I2 value equal to 1 divided by 2 pi into what is the distance value 1. So by solving what we will get 2 into, so this is very simple, everything multiplied by 1. So this pi and pi get cancelled, 4 divided by 2 is nothing but 2 into 10 power minus 7. So 2 into 10 power minus 7 Newton per meter, which is option D is the right option. Okay. Then in the left hand rule, forefinger always represents, see, we'll go to the previously we have seen which one represents the forefinger, represents the, see, thumb finger force, fourth finger magnetic field, centered finger current I. So forefinger represents the magnetic field. Okay, we'll see which one. This one. In the left hand rule, forefinger always represents magnetic field. Option C is the right option. Okay. Which of the following is a ferromagnetic material? Okay. Tungsten, aluminium, copper, nickel. In that, what is ferromagnetic material? Option D, nickel. Okay. Then wait, something is problem. Okay. Sorry for the inconvenient. See where we stopped. So which of the following is a ferromagnetic material? Is nothing but option D, nickel. Okay. Then 31. Ferrites are a subgroup of non-magnetic material, ferromagnetic material, paramagnetic material, ferrimagnetic material. Ferrites are a subgroup of ferrimagnetic material. Okay. Then Gilbert is a unit of electromotive force, magnetomotive force, conductance, permittivity. Hilbert is a unit of magnetomotive force. Option B is the right option. Okay. Then question number 33. The working of a meter is based on the use of a permanent magnet. Okay. In order to protect the meter functioning from stray magnetic field, what we need to do? See, meter is surrounded by strong magnetic field. A soft ion shielding is used. A plastic shielding is provided. A shielding of non-magnetic material is used. Okay. In order to protect the meter, we need a soft ion shielding is used. Option B, soft ion shielding is used is the right option. Okay. Then reciprocal of permeability is, reciprocal of permeability is relativity, susceptibility, permittivity, conductance. Okay. What is the reciprocal of permeability? Sorry, reciprocal of permeability is nothing but option A, relativity. Then question number 35. The relative permeability is less than unity is case of, we have already seen. So what is the this is option D. Okay. Okay. For relative permeability less than unity is nothing but diamagnetic material. For paramagnetic it is greater than unity, slightly greater than unity. For ferromagnetic it is very greater than unity. So for relative permeability less than unity is the case of option D, diamagnetic materials. Then which of the following is the unit of magnetic flux density? Magnetic flux density, what is the unit? Actually, what is the unit for magnetic flux density? See, 4 different options: Weber, Lumens, Tesla, and none of the above. So magnetic flux density is nothing but Weber per meter square. Weber per meter square is otherwise called as Tesla. Okay. Option C, Tesla is the right option. Magnetic flux density, again I am telling, unit is Weber per meter square or Tesla. Okay. Then question number 37. The magnetism left in the ion after exciting field has been removed is known as, so the magnetism left in the ion after exciting field has been removed is known as option B, residual magnetism. Permeance, residual magnetism, susceptance, reluctance. So magnetism left in the ion after exciting field has been removed is known as option B, residual magnetism is the right option. So question number 38. Which of the following is not a unit of flux? Not a unit of flux. See, It is very important. It is not a unit of flux. So Maxwell is also a unit of flux. Tesla is not a unit of flux because Tesla, how can we explain Tesla? Tesla is magnetic unit of magnetic field intensity, magnetic flux density. So magnetic flux density is nothing but Weber per meter square or Tesla. So for flux only we can say it as a Weber or Maxwell. Okay, so Weber also a unit of flux and Maxwell also a unit of flux. So which is not a unit of flux? So Tesla is not a unit of flux. Option B, Tesla is the right option for this question. Then question number 39, which of the following is expected to have maximum permeability? So options: brass, copper, zinc, ebonite. Maximum permeability is nothing but option D, ebonite. 1 Tesla is equal to 1 Weber per meter square. See, 1 Weber per meter squared. Option C is the right option. Okay. Then question number 42. Out of the following statements concerning an electric field, which statement is not true? Okay. Which statement is not true? Let's see one by one statement. The electric intensity is a vector quantity. Yes, it is a vector quantity alone. But what is given in the question? Which statement is not true? So we need to identify the false statement. So this one is a true statement. Then electric field intensity at a point is numerically equal to the force exerted upon a charge placed at that point. It is numerically equal to that. So it is not correct. Okay. Then question, we will see rest of the options also. So the false statement is B. We will check for rest of the options. See, an electric field is defined as a point in a space at which an electric charge would experience a force. Say, it is a correct one only. So then unit field intensity in the execution of force of 1 Newton on a charge of 1 coulomb. So okay, this is also correct. So option B is the wrong option. It is not a point is not numerically equal to. So option B is the right option for this question. Then next one, when a magnet is in motion relative to a coil, the induced EMF does not depend upon. Read the question carefully. We'll see 4 options: resistance of a coil, motion of the magnet, number of turns of the coil, pole strength of the magnet. It is not depend on resistance of a coil. Option A is the right option. Okay. Question number 44. 1 Maxwell is equal to same options are given in 4 okay. So 1 Maxwell is equal to 10 Webers. So 1 Maxwell is equal to 10 Webers. Keep remind that. Then question number 46. When 2 ends of a circular uniform wire are joined to the terminals of a battery, the field at the center of the circle. See, I am reading again. When 2 ends of a circular uniform wire are joined to the terminals of a battery, the field at the center of the circle will be 0, will be infinite, will depend on the amount of EMF applied, will depend on the radius of the circle. So, what is the correct one? Option D, will depend on the radius of the circle. Then question number 47. Susceptibility is positive for option C, ferromagnetic substance. Susceptibility is positive for ferromagnetic substances. Option C is the right option. Then question number 48. 2 long parallel conductors carry 100 amperes if the conductors are separated by 20 millimeter. Okay, the force per meter of length of each conductor will be. So we know the torque developed by the force formula Ft equal to mu naught into I1. This formula is very important. Okay, we have seen many problems and related theoretical question, whether it is directly proportional, D is directly proportional, or current I is directly or inversely proportional to F, like that. There may be a chance of question related to this formula. So Ft equal to mu naught into I1 I2 divided by 2 pi d. Mu naught is a constant value. We know that 4 pi into 10 power minus 7. What is I1 and I2? Carry 100 amperes each. So 100 into 100 only, I1 and I2 equal to 100 only, so 100 square divided by 2 pi, 2 pi into distance d. D is nothing, 20 millimeter is nothing but 20 into 10 power minus 3. By solving this, we will get as 0.1 Newton as the answer, okay. Then we will see another problem. A 300 millimeter long conductor is carrying a current of 10 amperes and is situated at right angles to a magnetic field having flux density of 0.8 Tesla. It is Tesla, right? Okay. Then the force, magnetic flux density, right? Magnetic flux density is nothing but Tesla only, unit 0.8 Tesla. The force on the conductor will be, what is the formula? F equal to ILB sin theta. Okay, this is the formula. So what is I? Just substitute all values. I equal to 10 amperes, 10. What is L? L is nothing but length in terms of millimeter. So 300 into 10 power minus 3 into what is B? B is nothing but magnetic flux density 0.8 into sine. What is theta? Theta value is given as right angles. Right angles, which mean that theta equal to 90 degrees. So sine 90. So by solving we will get 2.4. Now sine 90 is nothing but 1 only. So by solving, see which one? 10 cube, 3, 10 power 3 plus 3 minus 3, that will cancel. Then 3 into 0.8. 3 into 0.8 is nothing but 2.4 Newton. So F equal to 2.4 Newton is the right answer. Okay. Then another problem. What is that? A 200 coil having an axial length of 30 millimeter and a radius of 10 millimeter is pivoted in a magnetic field having a flux density of 0.8 Tesla. If the coil carries a current of 0.5 amps, the torque acting on the coil will be, okay. What is the formula for torque here? 2BILNR Newton meter, okay. Just substitute all values. So what is turn is nothing but n value, number of turns, n equal to 200. Then 30 millimeter is nothing but L, okay. Length equal to L. Then radius equal to 10 millimeter, okay. Substitute R as 10 millimeter. Then magnetic flux density equal to 0.8 Tesla, that is B. B value. Then what is I value? 0.5. We are having each and every value in the question itself. Just substitute in this formula 2BILNR. Multiply all these values into 2. We will get the answer as 0 something B. It is B, I think 0.048 Newton meter, okay. Substitute and find out the answer. Then this is the last one, last question in this session. 51. The electromagnet has 50 turns and a current of 1 ampere flows through the coil. If the length of the magnetic circuit is 200 millimeter, what is the magnetic field strength? Magnetic field strength, what is the unit? Ampere turns divided by meter. So ampere 1 into turns divided by 1 into 50 divided by meter, 200 into 10 power minus 3. By resolving we will get 250 ampere turns by meter. Option B is the right option, okay. Okay guys, we have seen around 51 questions in this electromagnetism topic. So thanks for watching. We have discussed around many topics under ECE and engineering mathematics. We have discussed in microprocessor, communication system, digital at a previous year, TNEB, which will be helpful for you to solve or attend GATE exam, TNEB, assistant in TRB polytechnic exams like. So kindly check with the playlist. If you haven't seen those playlists, kindly subscribe our channel and click on the bell icon. Then only you will receive notifications as and when we upload videos. Thanks for watching. Like, share and subscribe.